Good morning, everybody. We're going to take a quick look at your homework, or at least at most of it, and then you can hand it in. It'll be collected. But for the first little bit, I just want to make sure that you guys are understanding this. I think we hit Pythagorean theorem over and over and over enough that hopefully these problems were pretty simple, but I'd like to make sure. So in this first one, you can see that 10 is the hypotenuse. So that would be the one that's all by itself. So you would have x squared plus 7 squared is equal to 10 squared. If we kind of fast track this a little bit, that would be that x squared plus 49 is equal to 100. If we subtract the 49, we get x squared is 51, so therefore x is square root of 51. Okay, on this next one, we've got 12, y, and 16. Again, 16 in this case is the hypotenuse. So that's the one that's got to be all by itself. I've had some people messing these up where they're just automatically taking whatever numbers they see, like 12 and 16, and say those must be the ones I add up. But you got to remember, whatever the hypotenuse is, that's the one that's always by itself in this equation. Okay, and so for this one, you square it and you're going to get 256 for 16 squared. You're going to get 144 for 12 squared. And when you subtract that, you get y is equal to the square root of 112. All right, for this next one, you should have 8 squared plus 14 squared equals z squared. Okay, so that's 64 plus 196 is equal to z squared. If you add those up, we get 260. And that's not what z is, but that's what z squared is. So therefore, you can say z is equal to the square root of 260. All right, for number 4, again, you've got the hypotenuse has been given to you, so make sure you write it that way. So you got 3 squared plus a squared is equal to 4 squared. And that's easy. That's 9 plus whatever that is equals 16. If you subtract the 9, then you know that a squared is 7, so therefore a is square root of 7. On number 5, I've got the hypotenuse, so that one's got to go by itself, 22 squared. And so I know that 20 squared plus b squared has got to equal that 22 squared. And that's going to be 400 plus b squared is equal to, what is that, 484, I think? And so with that, then I can subtract the 400, and I say that, well, b squared has got to be equal to 84, so therefore b is equal to the square root of 84. And last one, this is real easy. You've got two that are the same size, 18 and 18. And so I know 18 squared is 324. So this is going to be 18 squared plus 18 squared is equal to c squared. So I got 324 plus 324 is equal to c squared. Double that, and what do you get? 648 is equal to c squared. So therefore, c is equal to the square root of 648. Not too bad. All right. The next section, we were trying to find the area of the shaded region, okay? Not just the area as a whole, but you got to find the area of the shaded region, which is a little bit weird on this first one, number 7, and a little bit on number 9, because they're cutting the whole triangle in half. And now we know that area of any triangle is equal to 1/2 base times height. But I kind of don't like the fact that they cut the first and last triangle in half, because then that kind of messes with, well, do you have half and then half of that? And anyway, but so here we go. Either way, the first thing you got to do is you got to find the height. Okay, I got to find the height. I know that this part's got to be 20 because the whole thing is 40, and then this hypotenuse is 29. So that means that 20 squared plus whatever the h or the height is squared has got to be equal to 29 squared. So that's going to be 400 plus h squared has got to be equal to, what's 29 squared? 841. And subtract that, you get that height squared has got to be 441. And if you actually take the square root of that, that's 21. Now, maybe you didn't know that, and it's completely okay if you have square root of 441. I'm completely okay with that. But you still got to finish the problem, okay? And to finish the problem, what I do is, let's see here, get rid of some of this. I've got to use that height in the equation. So I say area is equal to 1/2 base times height. Well, the base is only 20 because it only wants the shaded region. So I say the area is equal to 1/2 20 times 21. Well, 1/2 of 20 is 10. 10 times 21 would be 210. Or you may have had 1/2 times 20 times the square root of 441. And I'd be okay with that. And so that would end up being 10 times the square root of 441. Not an ideal answer, but it's okay if that's what you got. All right, so no big deal. All right, next one. This one, they got the whole thing, but again, if we're looking at this triangle kind of sideways, I'm going to say, well, this still is kind of the height, and so we've got to find that part. We know that this part must be 6. So we get that 6 squared plus whatever the height is squared is equal to that 14 squared. So this gives us 36 plus the height squared is equal to 196. Subtract that. Height squared has got to be equal to 160. So the height is equal to the square root of 160. And plug that in. You get the area is equal to 1/2 the base, which is 12, times the height, square root of 160. And half of 12 is 6. So I can say 6 times the square root of 160. And for number 9, lastly, this part right here is 35. Got to find this part. I'm going to call that h. So I know that 35 squared plus whatever the height is squared is got to be equal to 41 squared. Now 35 squared is 1225 plus the height squared is equal to 441 is what, 1681? 1681 squared? 16, I think. Yeah, we'll say 1681. All right, and then you go ahead and subtract, and you get that the height squared is equal to, you got to subtract these. What do you got? 76, 56, 456, I think. Yuck. Anyway, and so therefore the height is equal to the square root of 456 because there's no clean square root of 456. And then I got to plug that in and say, well, area is equal to 1/2 the base, which now the base is not 70, it's only the 35. 1/2 the base, 35, times the square root of 456. And so half of 35, that's like 17.5 or 17.5 times the square root of 456. So hopefully those are the answers that you got at this point. All right, so right now we'll go through the answers on the rest, but I just want to go ahead and you can pause the video right here. We'll collect the homework, and then we'll take a look at how to do the last 6 problems. Okay, so the last 6 problems, here we go. It says, classify each triangle as acute, obtuse, or right. And what we said, how we were going to do this is we use the converse of the Pythagorean theorem. Okay, if we have 3 numbers and they fit into this equation, then they must be the lengths of sides of a right triangle. But if the 3 sides of a right triangle don't fit into this equation, well, then it can't be a right triangle. But we can figure out what kind of triangle it would have to be. So let's start with the 6, 9, and 10. So I'd say 6 squared plus 9 squared is got to be equal to 10 squared. And really, it's a kind of a question mark. Is it equal to 10 squared? Well, that would be 36 plus 81 is equal to 100. But 36 and 81 is 117. And so it's not equal to 100. And the question is, well, what kind of triangle would it be? Well, what would be the hypotenuse, this 10, ends up being too small. Okay, notice that this 100 is smaller than the 117. And so what I want you to do is you can picture a right triangle, okay? And let's say that all of a sudden, though, in our right triangle, the hypotenuse was too small. It only reached to, say, here. Well, then the other side would have to kind of make up for that, and it would have to close in a little bit. So this angle right here would stop being a right angle because it had to close in a little bit, and so it would have to be acute. All right? And so what that means is if the side that would be the hypotenuse is too small, then we must be dealing with an acute triangle. Let's try the next one. We've got 18 squared, 24 squared, and 30 squared. Well, 18 squared is 324, 24 squared is 576, and 30 squared is 900. And fortunately, those two do add up. And so we get 900 is equal to 900. So that must be a right triangle. All right, the next one. We say 20 squared plus 100 squared is equal to 110 squared. All right, I can't remember how big 110 squared is, and I don't have a calculator within reach. But I know that this is 400. This is 10,000. And I know this thing is like 12,000 and something. So if I've got 10,400, that's definitely not equal to 12,000 and something. All right. And so what would you look at? You'd say, well, the hypotenuse in this case is too big. It's too big. And so again, picture that right triangle that you could think of. And now think, what if I made that hypotenuse bigger, maybe even significantly bigger? How would the triangle adjust? Well, this other side right here would have to kind of fold back to make up for that. And when it folds back, this stops being a right angle, and this angle right here becomes obtuse. So if what would be the hypotenuse is too large or too big, then this must be an obtuse triangle. And that's how this works. If the side that would be the hypotenuse is the right size, then it's a right triangle. If the side that would be the hypotenuse is too small, then it's acute. And if the side that would be the hypotenuse is too big, it's obtuse. All right? With that in mind, let's try these last three. So we say 7 squared plus 24 squared is equal to 25 squared. And that gives me 49 plus 576 is equal to 625. You know, fortunately, 49 plus 576 is equal to 625. So that means this fits. So therefore, it's a right triangle. Okay, 2 squared plus 5 squared plus 6 squared. Well, that would be 4 plus 25 and going, is that equal to 36? No, 29 isn't equal to 36. And so what's wrong? The hypotenuse, I wrote plus, I meant equals. The hypotenuse side is too large. This is too big. It's not equal and it's too big. So this must be an obtuse triangle. And lastly, on this number 19, we've got 13 squared plus 21 squared equals 24 squared. Well, 13 squared is 169, 21 squared is 441, and 24 squared is 576. So if I add these, I get 610, I think, is equal to 576. Well, that's clearly not true. And what's wrong? Well, the side that would be the hypotenuse is too small. So the fact that it's too small must be acute. All right, so that's what we got to try to remember. If you didn't quite pick it up, I know we touched it at the very end of some of the classes last time, and it was fast. So if the side that would be the hypotenuse is too small, it's acute. If it all fits, it's just right. And if the side that would be the hypotenuse is too big, it is obtuse. Some people start paying attention to the number on the other side of the equation, but I just focused on the one that's all by itself. I think that's a little bit easier. All right, I hope that worked, and I hope this helps. You guys have a great day.